Now we talk about the set theory, right? The set theory here. Okay. The set is a collection of the distinct objects. They call the element of the set, right? And think about this one here. You have the sum example. You have the first number. You have the first set here. You have the 4 elements. You have the 1, 3, 9, and 12. And the second one, you have the 7 element here. You have red, orange, and so on. Now we have the sum of the definition. The first thing is a subset. The subset of the set is that if you have every element in that set belong to the element of the other set here, right? That is a subset here. And think about this one here, right? You think about think about this one here. You have the set C, you have the 2, 3, 4, and 6. And you have the set B here, you have the 2, 4, and 6. So in that case, B here is a subset of the C, right? Because every element of B, you have 2 here inside the C, right? You have 4 here inside the C, and have 6 here inside the C. Right? In that case, they call it a subset. So the B here is a subset of the C because every element of B belongs to the element in the C here. Make sense? Okay. Now we have union and the intersection here. Union of the two sets contain all of the element contained in a set of the both set here. You can think that union is all. Now think about union is all function here, right? So we can think about this one here. I have this. Sorry, think about this one here. I have the set A. I have the set A. I have the 1. I have 2. I have 3, and I have the set B. I have 3. You have 4, and 5 here. So if C is the union of A and B, if C is a union of A and B, they put this one here, the sign here, right? This one is union. If C is the union of A and B, so what do you think? What's the element in the C here? What's the element you have in the C? What do you say?
All of A and B.
Yes. So what are they?
1, 2, 3, 3, 4, 5.
Yes, 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. Remember, they are the element in the set. It must be distinct. They cannot be the same, right? So in that case, you have the C. You will have the 1. You have the 2. You have 3. You have 4. And you have 5, right? So in that 1, 2, 3 belong to the A, right? And 4 and 5 here belong to the B, and so 3 also belong to B also, right? So union is that it has every element either on A or either on B here. Okay, so for this one also, you have A is red, green, and blue, and B is red, yellow, and orange. And when you C is union, sorry, C is red, orange, yellow, and green and purple here. Now tell me here, what is the union of A and B? What's the union of A and B here?
Red, green, blue, yellow, orange.
Yeah, okay. Now, so we move to the second definition, the intersection here. So now think about the union. You can think about, when you think about union, you can think about this. It's all function here. Right? It's all either on A or in B here. Now, the second definition is the intersection. Intersection, it is the set that every element of the intersection belongs to the both of the set here, right? It belongs to both of the set. Right? So think about this one here. The only elements that belong to both of the set here, the intersection, you can think this is a symbol of the intersection here, right? So basically, you see, if you have the A is the red, green, and blue, and C is the red, yellow, and orange. What do you think? What is the intersection of A and B? What do you think? What they have in common? That's the thing. Normally, in order to find the intersection, you have to find what is the in common. What's the in common between the A and B? Red only, right? That's red only. So you can think about the intersection here. you can use the and function here, right? The and function here only in A and in B, right? And the third definition here is the complement. Complement is the set A contain everything. It's not in the set A, right? It's not. Okay, complement of the set A is contain everything. It's not in the set A. So we see what was this one here. Everything complement is not on the set A, right? So if you think about this one here, if you look on this example here, what do you think? What is the complement of A and intersection with the C? When you work concentration with the C here. That is satisfy everything not in A, right? Satisfy everything not in A. So red cannot be, right? You see the red here cannot be. It's only A here. Red cannot be. Green here cannot be. And blue here cannot be, right? So you can see the complement of this one. It has the orange, yellow, and purple here for this one. Okay, also we have the interval set. That is the content of all elements we are interested here. Now, I think normally in the when working with the set, you use a Venn diagram here. You use a Venn diagram, right? So in the Venn diagram, you can see it's very clearly on this one here. Think about you have the two set here. You have the two set, right? You have the two set here. You have two set. Think about this one. You have 1, you have 2, you have 3, you have 4, and you have 5 here. Right? And for this one, you have 6, you have 7, you have 8, and 9. You think about this one, you have the set A, and this one, you have the set B here. Right? That is the Venn diagram. So now, if you want to find out the A union B here, you have to count every element in A or in B here. Right? That is union here. So what do you think? If C is the union of A and B, so what is the C? What is the C here? What is the C have? What does C have? Every element in A or in B. No. I say that union that either on A or in B is okay. Right? Either in A or in B is okay. So what do you think?
1, 2, 3, 6, 7, 8, 9.
No. See this one here. 1, 2, 3, 4 in A. It's correct, right?
Yeah.
Now, if you have to find every element in A or in B, so see 4 in A, 4 also in B. That's okay. That's okay, right? So basically, for this one, you have everything but 1. You have 2, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8, and 9. That union. Union here, that means every element in the union is either in A or in B. Right? So see, now 4 in A, correct or not? Right? Correct or not? So we think about this one, exactly is the all function here. All function. Right? So if you're in the A, it is correct here. Right? It's correct. Or it's in the B, it's correct here. Now we think about the union, it's all function here. Right? Make sense? Now, the union of the two sets, if every element of this set belong to the either A or B. You see, 1 belong to A, right? 2 belong to A, 3 belong to A, right? 4 belong to A. That's okay. I do not have to care about B anymore. Right? It already in the A. Now we think about all functions here. If I check the first condition, check correct. I do not have to check for the B condition anymore. Right? So see, 1 in A, 2 in A, 3 in A, 4 in A, 5 in A. Now I done with A. Right? So how about 6 in B? Also correct, right? 7 also in B, correct. 8 also in B, correct. 9 also in B, correct. It's all function here. Right? It's all function here. Now, if I have a C and have the A intersection with B here, What do you think? That means intersection, that means and tangent, that means what they have in common here.
That'd be 4 or 5.
Yeah, 4 and 5, right? Only 4 and 5 belong to both A and B. Only 4 and 5 here belong to both A and B here, right? 4 A, 4 B, 5 A, 5 B. That's the intersection here. Now, if you look on this one, what is the A complement for this one? A complement. If you look on from this one here, when you union with B, what is A complement? A complement, that means everything not in A. Right? So see, you have the 6, 7, 8, and 9 for this one. Right? So makes sense. So basically, the Venn diagram you can think about using the and or function here. And OR function. Remember that union it is the OR function. And the intersection is the AND function. Right? So you see, A union B, that means everything. Right? Everything in A or in B. Now, intersection here in both of A and B, and complement here, not in A. Not in A. That's all. That's everything about the definition about the set and the Venn diagram here. Now to move to the truth table. So basically, it's the last class also I mentioned about the truth table already, right? You have the sum of the basic you have the sum of the basic truth table here. I think about this. The first thing here, yes, new shade screen here. Yeah, right. And the first one, you have AND. The first one you have AND logic. Right? And remember that normally for the AND and OR, you have the 2 input and you have 1 output over here, right? So we think about here. You have A and B here. It is an input, and have the C here, the output here, right? Now think about this one here. The AND, remember that the output of AND logic only true when both of them true, right? Or you can think about true is the number 1 in the computer logic, and 0 is a 4 in the computer logic, right? So see, the output of the AND logic is only true when both of them true. That means you only have 1, and you have 1 here, right? See, both of them true, both of them input is true, the output here is true, right? You can think about this. I put it here. This is input here. Inputs. This is output. Now see, the output of AND logic is only true when both of them true. In any other case, it always 0 here, right? So this is, if you have 1 and 0 here, you have 0. You have 0 and 1 here, you have 0. And you have 0 and 0 here, you have 0. Right? That is 0 here. That is a true table for the AND logic. Now for the OR logic here. The OR logic, the output is always true when at least one of them is true. Right? Whatever, at least one of them is true. So we can think about for the OR logic here, you have input again, and you have output here. And the input, you have 2 input, you have A, and you have B, and the output you have C. Now for the OR, I remember the OR here, right? The OR here, the output is true when at least of them is true, and it's only 4 when both of them fall. Right? It's only 4 when both of them fall. So we see, if you have 0, 0 here, you have 0. In any other case, it's always number 1 here. Right? So we see, if you have one of them is true, you have true. You have one of them is true, you have true. And both of them true, of course, you have true here. That is OR logic. Huh? Okay. Now, the third one, you have the not logic here. The not logic, you only have 1 input and you have 1 output here. Not that means reverse, right? The reverse here. So think about, you have input here, input, and you have output here. So of course, you have input is 0, the output is number 1. not of 0 is 1, right? And you have inputs of 1, you have output is 0 here. That's all. Right? So basically, you have to understand about the truth table here when you work with the selection, right? Because you see, in the selection, you sometimes you have to use the compound logic. Compound logic, that means you combine them together, right? You can combine and OR many of them, right? Think about this. You only eligible to go to the army when the age greater than or equal 80 and weight greater than or equal 140. That's the AND logic here. That is, you have to understand about the truth table here, right? Sometimes you also use the OR here. OR is not here. You are totally flexible with the truth table here, right? Now, you also have some variety of the truth table, and you have the NAND also. The NAND, that means not AND. Right? NAND, that means not AND. That means it's reverse, you know that? The NAND is when the NAND logic here, right? The NAND logic here. You can understand it, it's a not AND logic. Right? So in order to find out the NAND, the first thing you have to find out AND function first, right? You have to find out the AND and you reverse it. You reverse it, right? See, now think about this one. Let me do it again, right? For the AND logic here. For the AND logic, you know that you have 0 and 0, you have 0, right? You have 0 and 1, you have 0, you have 1 and 0, you have 0, and only true when both of them is true, you have true. That's AND, right? That's the AND logic. Now for the NAND here. NAND here. That means not AND. Not AND, that means reverse of AND. Right? The reverse of AND. So see, the output is the input always the same here. 0 and 0 here, but you have to reverse the output. Right? You have to reverse the output. Right? Not of this. You have 1 here, right? 0 and 1 for this one, you have 0. 0 and 1 here. You reverse it, you have 1 for this one. Right? You have the 1 for this one here. And for this one, you have 0 and 1, you have 0, 3, right? 1 and 0 here, you have 1. Right? And for this one, 1 and 1, you have 0 here. Right? You see, this is the AND, right? And not of AND, you have NAND here. That's all. You can think about this one, right? You can think about this one here. And of course, you can do with anything. You can do with a not all here also. Right? So not all, that means you find out the all and you reverse the output, you got the not all here. Right? Okay. Make sense? Okay. Any questions so far, guys? Okay, now we move to the logic gate. You see, the logic gate here, the NOT gate, you only have 1 input and 1 output, right? And NOT, that means reverse. Yes, the NOT here is reverse here. That means you have 0 in, you have 1 out, and you have 1 in, you have the 0 out. That's all. That's the reverse. Right? And now we have AND logic. AND logic, you have 2 input and 1 output. That I mentioned it already, right? You mentioned it already. All logic, you have the 2 output and have 1 input. The NAND is the reverse of the NAND of the AND, and the NOR here is the reverse of all. Right? Also, we have one of the function here. We have the XOR here, the exclusive OR. Right? The output, only 1 input is allowed to be the positive. 1 or to give the positive. So think about this here. If you have the XOR here, you have the XOR here, you can think about this one here. If you have 0, sorry. You have 0 and 0, you have 0. If you have 1 and 0, you have 1. And have 0 and 1, you have 1. And you have 1 and 1, you have 0. Right? that is exclusive OR here. When both of them is the same, you have 0, but they are not the same, you have number 1 here. Right? That is exclusive OR. So basically, you have the sum of the very basic truth table and logic gate. You have to understand about the AND, about the OR, about the NAND, and there's a NOR here, and there's NOT also. So I think that's all for the discussion and homework here. Now, the next thing I want to work with some of the Python here, right? Because in the homework you have some of the homework assignment working with the Python, right? So basically, when working with the Python, when work with a single alternative, it's very simple. It's very simple. And the structure here, you see the structure when you work with the Python, you have the if and you have the condition to check here, and after that you have the double column. That's all, right? And in that you have the statement to do it, and if not, you do nothing here. If you do not anything. If you think about this one here, this is a single alternative. Right? I get the H from the end user. Right? And remember that in the Python, right? See, in order to get the input, you have to use the function input here. Right? You got it, right? And by the default, whatever you got from the input function, it always is the string format. Right? It always string format. And in order to work with the number, you have to convert it to the number format. And you have 2 functions to convert it. What are they? I mentioned it on the first class already. What are they? What are they? Yeah, integer. If you want to convert it into the integer format. What else? Yeah, float, right? You have the 2 functions. You have the 2 functions here to convert the number. Yeah. All right. So think about if you want to get the salary about the 4,000, 4,500 and 51.75 here. You know this one it is a float, right? So we have to use the function float here to convert it. But now you see, for H here it is a integer number, right? That's why you use the int here to convert it into the integer number, right? So now, once I got the number of H here, I check the condition. I check the condition here, right? If the H greater than or equal to 18, you are eligible to vote. That's all. That is very simple example in the Python here when we work with a single alternative here. Single alternative here, right? So we see when I click on this one here. Okay, so see, that is a very simple example when we work with a single alternative here, right? So what happened here? What happened? What happened if after the user enters the number 10? What do you think? What happened? If the user enters the number 10, what happened? For this one? For this coding? What happened? Huh? Yeah, don't do anything because it's a single alternative, right? Yeah, single alternative. You check the condition true. If it's true, you do something. You do something. If no, you do nothing. That's a single alternative here, right? So if you enter the number 10, you do nothing here. And of course, if you enter the number 20, the condition here, it is true, you do something, you print out, you are eligible to vote here. Okay, that is a single alternative. Now, in the Python, sorry, interrupter is very simple, right? Interrupter is very simple. If you run with a single alternative here, where my raptor one. Oh no. Okay. So in the other, right? Now see for this program here, the first step you have to get the age from user, right? So with that you need to get the input here, tell the user, right? And right? And you store it into the variable name age here. Now see when you got the age to do with the selection, you have the symbol here, right? You have the symbol here, the selection here. You drag and drop the selection. Now the condition here to check if age greater than or equal 18, right? If yes, user print it out. Of course, if you want to print out, we have to use the output here, right? You use the output here, print out. You that's all. Right, so we run it here. Of course, when you enter the number 10, nothing, right? Nothing happened, right? But if you enter the number 20, you are eligible to vote here, right? So it's very simple when you work with the router or the Python when you work with the symbol underneath it. So you run it here, Python, and the edge 10, nothing happened, right? And run it again. I have a 20 here. You are eligible. Right? So now that is a single alternative. Now, if I want to do with a new alternative, I just work with another branch here. I work with another branch here. Now think about this one here. I can modify the previous program, right? So if age greater than or equal 18, you are eligible to vote. Else that means you are less than 18, right? You are less than 18. Right now, you are not eligible to vote here. So basically, it's very simple when you work with the Python here, right? When you work with the Python here, you can modify the program. You can modify the program here. You just copy this one, this here, and this one here. You put it else here. Remember, you have to use the double column here, and you are not eligible. Huh? So basically, you see, when you get the age from the user, right? And check the condition here, age greater than or equal 18. Print now, you are eligible to vote. And else that means not correct. Not correct. What's the meaning? Not correct. Not correct. That means you are less than 18. Huh? So print now, you are not eligible to vote here. Now see, now if you run it, you will have the age here number 10, right? You are not eligible. Right? So in the router also, in the router you do the same, right? You do something with the node here, but you copy quick or this one. That's it. Right? And I change it to the node here. Okay? That's all. See, when I run it here, right? So when it does age number 10, you are not eligible to vote. Right? Number 10 again, you are not vote. And number 20, you are eligible. Okay, makes sense? So basically, it's a both of the single alternative and the dual alternative in both of the router and the pseudocode. It's quite simple here, and it's very, very straightforward. You can see it clearly on this one. Now we move to the how about netted decision? How about the netted decision? Now that is an example. We work with the netted decision, right? So we think about this one here. For the netted decision, you have to put the selection inside another selection. Inside another selection here. So in the router, in the Python, and work the range function here. Okay, when you work the range function, I think I have. Yes. Now see. I think this one is what I think. Okay, so that is when we work with the Python, right? You break it down into multiple branches here. You break it down into multiple branches here, right? So think about this one here. The logic it work always the same. The logic it work always the same. If you look into the right requirement here, right? If you look on the requirement here, it break it down into the 1, 2, 3, and 4 branches here, right? You break it down into 1, 2, 3, and 4 branches here. So when you go back to this one, basically is the program here, right? So you have the range from 0 here. You have the 10. You have the 24. And you have the 50. And more than 50 here, right? So see how it works here. Now you check. Now when you got the item, right? You got the item order from the user here. You check if the item order less than the range number 1. That means less than this one here, right? Less than this one. Just do it, right? Just do it. Print out the discount and access the selection. If not, right? If not, you have to check here if it's less than the 24 or not, right? Of course, you see when you check for the less than the range number 2. You do not have to check it greater than the range number 1 anymore, right? Because it will check on the first one here. And it do so on. It do the so on with the other one here. And in the after, it will also the same, right? In the after, also the same. You can see in the after here. In the after here, you see, you put the selection inside another one here. That's the next decision, right? Next decision here. So you see, again, you have the line here. Again, you have the line, everything from 0, you have the 10, you have 24, and you have 50 here. Now we check if the number of item less than or equal to 10, you just print out 0 here, right? And you exit the selection, right? And now, again, if not, right? If not, that means you can check again if it's on the range here or not, right? So check if less than range number 2 or not. If correct, I print out this count number 2 and I exit the selection here. And again, if not, check out for this one here. Check out for this one. If less than, right, that means you have in the range here and print out. And of course, the leftover is everything here, right? Right? And that is a structure when you work with the raptor here. Any questions so far? Hello?
May I see the Python code for?
Okay. Yeah. So we see if you with the Python and the Raptor, you can see they work exactly the same. The structure also exactly the same. You can compare it. You can compare it. So you work exactly the same, right? Work exactly the same here. Right? See, check for the first range here. Check for the first range. Right? If not, check for the second range. Check for the second range here. If not, check for the third range. Check for the first range here, right? And if not, of course, you have the leftover, and you have leftover here. That's all, right? And do the same. You do the same with the structure here. And remember that you also have to understand about the structure in the about the structure format in the pseudocode. In the pseudocode, you have if, then, else, right? And if, else, and if else. And you can see they are netted together in this one. Hello? Any question? Yes.
For the Python, how would you declare the items ordered variable?
Item order. Item order that you got it from the user. Right?
Okay.
Item order is the same. The same when you do this one here. Alright, so the same. You got the item order, you got it from end user. Right?
Oh, okay. Yep.
Okay.
Thank you.
And you see, you have the sum of the constant here, right? You put the constant at the end, sorry, at the beginning of the program. And see, you got it exactly the same. The way you got it exactly the same. You got it from end user. Right? You got it from the input function and you convert it into the integer formatting. Now I go with the sum of the homework here. Okay, so I think that I see that some of you already did it with the discussion here, right? In the discussion, remember that you have to work with the NAND gate here. Right? Remember the NAND gate that is not AND, right? Not AND. Right? That's revert of AND or OE. So I do not have to go to back for this one. Now we go with the debugging. Right? This is about debugging here. Debugging. One. Okay, so the first suggestion whenever you do with the pseudocode, you have to read everything here. Have the command. You have to understand what is the purpose of the program, right? Once you understand the purpose of the program, you can see what the logic is. So this program here, basically for this program here, this program, right? The program accepts the ID number and name of agent who rents the apartment, room, the commission here. Okay, so we can think about this one here. This program here keeps asking user to enter the name and ID, right? And for each of the agent, you have to tell that you rent out apartment with how many room, right? It can be 3, can be 2, or can be 1 or 0 with studio here, right? So now you have to do it for many employee. Many agent here. All right. Now, if you look on this program here, the first step you want to do the pseudocode here. Right? The first step you understand this structure, right? You have to understand the structure here. Okay, do the same, right? You have get ID. Get ID, that means prime input or housekeeping, the same, right? And inside you have the main loop here, right? Of course, you have the finish here and the job. Right? So this one also follows the same structure, the same mainline logic here. Now, see, get ready, it is a prime input. That means you need to get ready for the loop, right? Outside the loop, before the loop here. So if you want to find out what do you need in the get ready, you have to look in the while. You have to look on the while condition here, right? And you see, if the salesperson ID is not equal to the quit, that is not equal to 99. It keep doing it, right? So you see the condition here, you check the salesperson ID is not equal to 99. You know that for sure. In the prime input, in the get ID, you need to get the salesperson ID, right? You not revert it back. You not change back here. You see why? What is the why condition here? Why you have to check the salesperson ID? Right? So we know that in order to check it, you need to get something ready here in order to check. That's why you got the syntax error here, right? So see, now you see for this one here, what wrong with this one? What wrong with this one here? Now see, when you go with the get ready, right? When you call the get ready, here's the function. You know that, right? The function did jump into the get ready. What the get ready here? And there's a salesperson ID. That is correct. You need the salesperson ID, right? Or quit to quit here. But what wrong with the get ready? What wrong with the get ready here? What do you think? Huh? Yeah, actually this one you have to use the input here, right? Output here is the prompt. Output here is the prompt. Tell user what they have to do, right? But when you got the something from the user, you have to store it into variable name. Right? That's why you have to use the input here. So basically, you have to change it to the input. You have to change it to the input here. And anything else? Anything else? Anything else for this one? Come on.
Oh, never mind.
Anything else? Anything else? Yes, you see, inconsistent variable name, right? You see, this one is not the same here. Sorry. You see, this one is not the same as this one, right? They are not the same variable name. You got the syntax error for this one, right? You got it. Okay, so now see, you've done with the get ID, right? You've done it with get ID. You got something with the salesperson ID for the first one. You go to the loop here, right? Why the salesperson here? You go to data loop. What you have in the data loop? You got the name of the agent, right? And of course, you get the number of room rented from the agent here, right? So now that is actually this is a netted decision here. That is netted decision here, right? You check if the number of room 3, 2, 1 or 0 here. So what's wrong with this one? What is wrong with this one here?
The number of beds, the if number of beds is greater than 1 should be less than 1.
Sorry?
Or it should be.
So here the thing. This one is working with the range here, right? This one working with the range. You have 0, you have 1, you have 2, and you have 3 here, right? Range here. Now we can check it. Check the first thing here. If the number equal to the 3 or greater than 3, whatever, or equal to 3, you have the commission 3, right? If the 2, commission 2, and so on here. So what you have to change for this one? What have to change for this one? What is it? What do you think?
The less than 2 and greater than 1 variables check the same thing.
What?
So if num bedrooms is greater than 1 and if num bedrooms is less than 2, greater than 1 and less than 2 are checking the same thing.
Okay, but how we correct it? So here in this program, you only have the 4 probability. I only have the 4 condition. It can be the 3 room, 3 bedroom. It can be 2 bedroom. It can be 1 bedroom or no bedroom. Right? It only have the 4. What is it? You only have 4 output here. Only, right? It can be 3 bedroom, can be 2 bedroom, can be 1 bedroom or 0 bedroom. 0 bedroom, that means the studio here. And for each of them, they have the COM3, the commission 3, that is for 3 bedroom. Commission 2 is for the 2 bedroom, and commission 1 for the 1 bedroom, and commission 4 is for the studio. Okay. Now, what's wrong with this one? What's wrong with this one here?
Then the if number of bedrooms should be greater than 2.
This one?
Yeah, not less than 2.
Okay. Now tell about what happened. What happened if the agent got the number of bedroom with the number 3? So what the commission rate she had? Yes, actually this is correct one. All right. So now tell me in this one here, what happened? What happened if the agent got the rent for the apartment with 3 bedrooms? So what happened? What commission rate she had?
It would be the commission 2.
Yeah, right. Yeah, that's wrong, right? See, if she entered the number 3 here, the condition here is not correct. Right? 3 cannot greater than 3. So basically check for this one. Of course, this one correct. So basically she got the commission 2 only instead of number 3. You got my point? You got it? Okay. Now see, if she enters the number 3 here, right? We check with the condition here. Number 3 here. Sorry, check the condition here. Number 3 here. Greater than number 3. Not. Right? Not. 3 is not greater than 3. So not correct. So when not correct, you have to move to the next one, right? You have to move to the next one here. See, not correct. You have to move to the next one. Now, number bedroom greater than 2 is correct, right? So she got only the commission for the 2. Now, so how we correct it? Yes, the guy on the chat here to correct, right? So the first thing we have to check if equal, sorry, you have to put here if greater than or equal to the number. Equal also. I have to put equal. So is that if she rent out the 3 bedroom or 4 bedroom, she only has the commission 3 here. Now, what do you have to correct for this one? The second one. The second one. What do you have to correct for the second one? Now see, you can think about this one here. You have the range 0 here, you have 1, you have 2, and you have 3. Right? You already checked the condition for the first one with this one already. Right? Now we move to the second one. You move to the second one.
The same thing.
So how do it? How we change it?
It'll need to be the greater than or equal to 2.
Yeah, right. Yeah, you only need to greater than or equal to 2. Right? Right? Because here, this is not 1, right? And you check if it move 1 here. Right? And about this one also. And so the leftover you have the 0 here. Okay? Now that is structure of the selection here. Right? You see, at the end of the loop, also have the action here to get the salesperson ID of the next agent here to start over the loop. Right? So the structure here is correct already. Now, any question for this one? Let me know. Any question? So once I correct it on the class, I hope that you have to do it correct from the homework. I don't know why. In the last week, I only correct you with the 2 homework, 2 pseudocode, but many of you is not correct when you submit it. I believe that you are not, even that you, I check attendance, you are here, but you are not engaged in my class.
So
Yeah, tell me, what is it?
for the if numbeds is greater than 1, could it just be equal to 1 instead of greater than or equal to 1?
Which one? This one?
Yes. Yeah.
No, this one here. Actually, this one you have many ways to do that. Right? You have many ways. You have the greater than or equal number 3. So that means for every 3, 4, 5, 6, 7, you got the code. For this one, you can change it to number 2. It's okay. Okay. Because you cannot, if you are not greater than or equal to 3, you can equal to 2 here. Or you can check equal to 1 here.
It's going to be
or it's the same. If greater than or equal, it will work the same. Greater than or equal work the same. So see, you cannot greater than or equal 3, you cannot greater than or equal 2, you cannot greater than or equal 1. You only have one symbol 0 here. That's the last one. That is a stereo here. Makes sense. Okay.
So since we're dealing with whole numbers,
yes,
we don't have to worry about decimal at all.
Yeah, right.
There.
That's the point. That you work with the integer number. Number bedroom over 1, 2, 3, 4, 5, right? So basically, you do not have to use the greater than here. You can directly put the equal here. It's okay. Yeah. Thank you. Now, again, you have to read about the purpose of the second one here. List that describes the annual profit static for the retail store in food records contain department name, profit for each quarter of the last 2 years. Program should determine whether the profit is higher, lower, or the same. Okay. Now, this program, right? This program. Now, what do you think? What is the output of this program? What is the expected output of this program? If you look on the header comment here, what is the expected output?
A list.
What is the expected output for this program?
Profit. List the profit.
Now you have to read. Yeah. What is expected? No, it's not correct. It's not correct. Expected output. What is it? Yes, of course, in order to go with the expected output, you have to figure out the profits. Huh? But it's not the final expected output.
So it's the last part there, it should determine whether it's
Yeah.
higher or lower.
Right? You just do, yeah. So in order to do that, the expected output here, you have to print out if this year higher, lower, or the same with the last year. Now see, in order to do that, you need to figure out what is the profit of this year and what is the profit of last year, right? And in order to figure out what is the profit of last year and this year, you need to get the input. The input here is the profit of each quarter here, right? So basically, you need to input a 4 quarter for the last year, and you need to input for the 4 quarter of this year. Make sense? Right. Okay. So see, for this one you see, you have the sum of the variable here, string department here. That are correct, right? You need the same quarter this year, quarter this year, quarter this year, last year. You see, also something wrong with this one already. Something wrong in the declaration already. Can you find out what is wrong with this one? What's wrong with the declaration here?
There's two things. There's the for the this year, there's no Q4.
Yeah, right. So actually, you need the 4 here, not 3, right? Makes sense. You need the same quarter this year, quarter number 1, number 2, number 3, number 4. And the last year also, you need the number 1, number 3, 2, number 3, number 4, and you sum it up. You have the total this year, and you have sum it up. You have the total last year. Okay.
Then, yeah, one of the last years says this year, the Q3.
Okay, this one also. Yes, yeah, you have to pay. Yeah, this one also. Right? This one is the last year here. Yes, this one is the last year. Now, you done with this one, right? You done with the declaration here. Now, see. Okay, you check in the Y statement here. What do we have to compare here? What's the condition in the Y here? Now tell me what's the condition in the Y here? In the Y loop here? In the loop here? What's the condition? Tell me what's the condition in the Y loop? In order to run the Y loop, what's the condition here?
It cannot equal with, does not.
Which cannot, department, right? Department cannot equal to which here ZZZ, right? So we know, again, translation again, right? Translation here again. In order to do that, you have to understand that you need to get the department from the housekeeping, right? That is the way you work with the pseudocode here. You see, the condition to go to the while loop here is when the department not equal to the grid, right? So in order to do that, you need to get that deal with the housekeeping. In the housekeeping, for sure, you need to get input from user with the department of the first department here, right? So now, again, chase down here, chase down here. So see, when you go with housekeeping, you have to look it now. You have to look it up. Where is the housekeeping? When you call housekeeping, you have to look here. Output department name or quiz here. Input that. Anything wrong with this one?
Variables.
Yeah, variable inconsistent again, right? You see, variable inconsistent again. Okay, you see, the while loop here, you need the department, right? Sorry. But this one here, you need to check the variable department here. Right? But this one is stored in the lab here. They are not consistent, right? And in order to find which one is correct, in order to find which one correct, you can come back to this one. This one you need to get the department here, not that here, right? Yeah. So you know what the Y here department is correct one, not that one. Make sense? Okay, so see, you have to correct this one. All right, that's the first step. Now, you're done with the housekeeping. You go to the main look here, compare profit here. The compare profit, you see, again, you have to understand about the structure here. All right, in the compare profit, what happened in the compare profit here? What do you think? What is it? What is it? What is it? What is it? In the compare profit, you get sales data here. What is the action here? What is the purpose of this action? What do you think? What is the purpose of this action?
Getting all the information from the user.
This action here is the call to function, right? It's a call function. And in order to understand that, this call to function name get sales data here. Again, you have to look it in the pseudocode here. What is the purpose of the get sales data? Get sales data here, actually you got everything from user, right? You need to get the 4 profits of the 4th quarter of the last year and 4 profits of the 4th quarter of this year, right? And of course, in this one also, you have many problems in the get sale here. What's wrong with this one? What's wrong with the get sale data here? What's wrong?
Quarter 2, like.
Yeah, right. You see, you need to get the 1st quarter. You store it in the sale 1st quarter, right? It's 1st quarter here, and you do the same. This is one here. You store it in the 1st quarter, store in the 1st quarter. Now 2nd quarter, you have to store 2nd quarter, right? And so on, and so on. For this year, you have to do it 4 times for this year, and you have to do it 4 times for last year, right? So when you got input everything in the get sale data here, you see, you have to, sorry. Okay. See, when you got everything in the get sale data here, you got the return. You know what? You got the return here. You got the return here, right? So when you return, that means you have to go back into the program. You have to go back to the program to look at it again. See, you get data, read everything in the get data, and come back and move to the sum of the sale data here. Okay, you have to check what is the purpose of sum of the sale data. What's the purpose of sum of sale data? You just sum it up for this year and sum it up for the last year here, right? And again, this one also have many programs in the sum sale data here. You have to find it out. So you see, you come back to the main loop here, compare profit. When you got the input from the user, when you figure out what's the profit of this year and what's the profit of last year, right? Now, that is the time you compare them together. Right? You compare them together to determine if it's a higher, lower, or the same here. And also, if you look at this one, what's wrong with this one here? What's wrong with this one? What is wrong with this one here? What's wrong with this one? What's wrong? It's very straightforward here. You can see what's wrong with this one.
The variables are
Which variable?
total this year, total last year. Oh, never mind.
It says like the first one says equals when it should be greater than. The second one says less than or equal when it should just be less than.
Okay, right. So think about this one. When you figure out the profit of this year and the last year, right? Now is the time for you to do the comparison. So you already have the three possibility, right? It can be greater than, it can be less than, or it can be equal here. Now, see, if equal, why put higher here? You have to put the same, right? Or if you want to keep it higher, you have to change it to the higher here. Right? And so on. You have to change it here. Okay, so this is the negative loop here, right? So check here. If greater than, right? If greater than or not, well, if not, check again. Less than or not, no. Less than or not, of course, you have equal here. You do the same here. If else, L, right? So you can. So I think it's the other way you can do it. You can convert it after you can see what wrong is. And of course, you see at the end of the loop, you will have the action here to get the input for the next department to come over the loop again. That's a good structure with this one already. Yeah. Okay, so at normal, I already happy with the first two pseudocode correction only. So I want to give you the leftover for you to do. Any question? Hello? Any question?
I'm good.
Okay. Now the raptor. Okay, so this one here, right? This one here, tell you, right? To tell you that you have to work with netted statement, right? Next statement. So basically, this one also very simple, right? You have very simple with this one here. So basically, in order to do this netted installation, you can think about this one here, right? You can think about you have the line here, you have everything from 0, you have the 16, and you have 18 and more than 18. So to do with this netted selection here, you can check if f greater than or equal 18. You want to do that one here, right? If not, you check again. If greater than or equal 16, yes. If not, less than 16. Make sense? Yeah, very simple when you work with the raptor with this one here. Very simple here. Now the second one, right? The second raptor is accept the tree grade from the user, right? The program figure out. So basically, you need the three grades, right? So we can put it to grade number 1, grade number 2, grade number 3. You got it from end user, right? You got it from end user. You sum it up together, and divide by 3. You got the average, right? So when you got average again, you check the condition, right? Check the condition here. If average greater than 60, right, pass. If not, fail. That's all. You need any help with this one? You think you can do it? Very simple with this one. Let's see what you have in the Python. So anyway, in the Python, also I believe it's very simple. So if you follow my my class, if you follow my my slide, you can see how we work with the Python, right? I instruct you how to work with the single alternative in the Python, dual alternative in the Python, and netted decision in the Python, right? And I will upload the slide later on the class in the announcement, and if you need for your reference, if you want it. So, any question? Let me know. Hello? Okay, so let me check the attendance here. Zachary Baker, are you here? No. Zachary Barrow, are you here, right? Cameron, are you here? Cameron, are you here? Here. Richmond, are you here? Emiliano, are you here? Emiliano.
Here.
Okay. Riley. No. Hayden, are you here? Hayden, are you here? Jasmine, are you here? Jasmine, are you here? Look, are you here?
Yeah,
Diego,
You,
Nick, Jose,
Yeah, I'm here.
Jack, are you here? Jack, are you here? No. Martin, are you here? Shalom, are you here?
Hello? Sorry. My
Who's that?
microphone was not working. Zach.
Okay. Nathan, are you here? Aiden, are you here? Aiden, are you here? Okay, so I think that's all for the class. I will cover everything. And anyway, if you need any help from me, you can study after the class. I let the Zoom meeting here. You can do with the homework, and if you need any help from me, just let me know.